Hey everyone, welcome back to day 9 of 100 Days of Solidity series. So in this video, we will learn global variables in Solidity. Okay, so what are global variables? Unlike our variables which we declare like public up right here, over here, there are some variables which we can access globally without declaring, by which I mean that they are predefined which we can access. Okay, so let's see one by one. So the first one is block.number. Okay, let's declare a variable. Let's say num equals block.number. Okay, so first thing, this is how you can access the first global variable block.number. And one thing to notice is that this is not being declared anywhere. This is accessible globally anywhere, anytime. Okay, so it represents the current block sequence number in the blockchain. Okay, it's increased by 1 in each new block. Okay, so if you go to the Ethereum blockchain, as you can see, this is the current block number. Okay, so this was the previous block number. Okay, so by which we can know what block number is the current time. Okay, like at present, what is the block number? We can get to know about that by using block.number. Okay, we will use it to like verify vesting periods or age-based restrictions. Okay, we'll do like that. Okay, if block number is less than this, we'll do some logic like that we can do. Okay, so the next one is block.timestamp. So we can use the same thing like this. Let's say event time equals block.timestamp. Okay, so this is how we can access block.timestamp. So what it basically means is it represents the Unix timestamp of current block's creation. Okay, so if we decode this block.timestamp, right, it's like the big number, like more big than this. What it basically represents is current timestamp. Okay, as you can see, this is the timestamp. This is the decoded value. But if we access it like this, we will get a big number, which we'll have to decode it. On decoding it, we will get the exact date. Okay, so this is the basic use case of block.timestamp. It's like mainly used in staking periods or token vesting and all those verifications. Okay, the third global variable is block.chainID. Okay, let's say like event chain equals block.chainID. Okay, so what this basically represents is it's a unique identifier for current blockchain network. Okay, so if you go to Ethereum, the chain ID of Ethereum is 1. Okay, so the same way there are different chain IDs like which are unique for separate chains like Binance, Polygon, and all those things. They have their own separate chain IDs. Okay, which you get to know, like which you can get to know by using a website called chainlist.org. Okay, it's chainlist.org. So make sure to visit it as well. Yeah. So the fourth global variable is message.sender. Okay. So we'll name an address variable here. Let's say address me equals message.sender. Okay. So what this basically represents is who sent a transaction. Okay. So if we deploy a contract, let's say we'll deploy the same contract. Let's do deploy it. Yeah. So if we call this function, which is public, message.sender basically tells us who called this function. Okay, so since I'm calling with this address which ends with C4, the message.sender will have the value of this address, which is this one. Okay, so this is basically message.sender. Like it's mainly used for owner only function checking, like if message.sender is equal to owner, we will do some logic like that. It's being used. Okay, so the fifth global variable is message.value. Okay, so for that we'll have to make this function payable, although we will see payable and sending ethers in later videos, but for now we will see a basic introduction. Okay, let's do payable and let's make it like this. Okay, for that we'll have to remove view and let's make an event and let's say value equals message.value. Okay, so what this message.value basically represents is how much ethers one sent to this contract. Okay, so let me deploy this contract again so that we can demonstrate. Okay, so once I deploy it up right here, if I call this up right here, okay, since I'm not sending any ether value up right here, like real Ethereum up right here, there is like 0 way. Okay, so if I pass 1 way and I call it again, as you can see, I passed 1 way. Okay, which is like too small amount compared to ether. You can even pass ether as well. Okay, let me call the function with 1 ether. Let's call day 9. As you can see, the balance updated to 1 ether. Okay, so we can access the current value which is sent in the present transaction. Okay, basically if you call this function at the time of calling, how much ethers you sent, that can be accessed by message.value. Okay, so this is the basic use case of message.value, and it's used for like verification, like if this person sent this much, we will give him some amount of tokens, or we will purchase him a ticket, or like that logic can be done up right here. Okay, so the final widely used global variable is tx.origin. So tx.origin, unlike message.sender, what it basically represents is it represents the original external account that initiated the transaction. Okay, it's actually different from message.sender. Okay, so if you can see up right here in Excalibur, okay, so if I am a user, I have two contracts. Okay, contract 1 can communicate with contract 2. Okay, if I call contract 1, which calls contract 2, for contract 2, contract 1 is the message dot sender because contract 1 called the contract 2, and tx.origin is user because he is the one who is creating the transaction originally. Okay, so this is tx.origin. We can access the original sender of the message, or let's say transaction, and this is the immediate caller who called this contracts function. Okay, so this is how a basic overview of transaction and message.sender works. Okay, so these are the 6 mainly used variables in Solidity, which we'll be using mostly in our projects, which we'll see in the further videos. Okay, I hope you guys got to know about the global variables. If you have any questions, make sure to comment it down below. I'll meet you guys in the next video. Take care. Bye bye.